Hey Mr. Golan, this is Matt, and today I will be teaching you how to find any angle using trigonometry. First, I'd like to begin by describing the four quadrants. In quadrant 1, the x-axis and y-axis are both positive. In quadrant 2, the x-axis is negative and the y-axis is positive. And in quadrant 3, both the x-axis and y-axis are negative, and in quadrant 4, the x-axis is positive and the y-axis is negative. This will be important when solving the example problems. An important note before beginning any problems is that x and y are the only two variables that can be negative. R, anytime you're trying to find r, it can never be negative. Next, I would like to talk about the trigonometry identities, which will come into play when we want to find the x-axis, y-axis, and radian of a missing angle. So sine of any angle is equal to y over r being the radian. Cosine of any angle is equal to x over r. Tan of any angle is equal to y over x. And cosecant is the reciprocal of sine, being r over y. Secant being the reciprocal of cosine, being r over x, and cotangent being the reciprocal of tangent, x over y. In order to find the missing x, y, and r, we will be using a famous equation known as Pythagorean's theorem with three missing variables, or with three variables in the equation, so it will fit nicely. In this case, instead of the original equation, we will have it set up as x squared plus y squared is equal to the radian squared. Beginning with our first example, we have sine of an angle is equal to 5 over 12, and this is in quadrant 2. As we know from before, quadrant 2, the x-axis is negative and the y-axis is positive. So we're looking for the cotangent of this angle. So we begin by setting up x, y, and r. We know that sine is equal to y over r, so y is equal to 5 and r is equal to 12. And so we're looking for x. By finding x, we set up Pythagorean's theorem. X squared plus y squared is equal to r squared. We don't know x, so we leave x as is. X squared plus 5 squared, which is y, is equal to 12 squared, which is r. So 12 squared is equal to 144, and 5 squared is equal to 25. 144 minus 25 is equal to 119. So that gives us x squared is equal to 119. Using basic algebra, take the square root of x squared and bring it to the other side, squaring 119, that gives you x. X is equal to the square root of 119. And because x is in quadrant 2, we know that it's negative, so it's actually the negative square root of 119. So now that we have x, y, and r, we can find the cotangent of the angle, which is equal to x over y. In this case, the cotangent of the angle would be negative square root of 119 over 5, x over y. So in the second example, we have the secant of an angle is equal to negative 7 over 4 in quadrant 2. We know that quadrant 2, again, is negative in the x-axis and positive in the y-axis. And we're looking for the tan of the angle. So we have x is equal to 4, we have y that we don't know, and r is equal to 7. And we know that 4 is negative because it's located in quadrant 2. X is negative in quadrant 2. So we have x is equal to negative 4 and r is equal to 7. So we're looking for y. We plug this into Pythagorean's theorem in part B. X squared plus y squared equals r squared. and that gives us negative 4 squared plus y squared is equal to 7 squared. So negative 4 squared is equal to 16, 7 squared is equal to 49, 49 minus 16 is equal to 33. Y squared is then equal to 33. We take the square root of y, bring it to the other side, and get the square root of 33 for y. Y is equal to the square root of 33. So now we have x, which is equal to negative 4, y, which is equal to the square root of 33, and r, which is equal to 7. We can now plug it into the tangent of the angle, which is equal to y over x. So plugging it in, we get the square root of 33 over negative 4, which is equal to negative square root of 33 over 4. Our third and final example, we have the tangent of an angle is equal to 3 over 4 in quadrant 3 this time. We know that quadrant 3, both the x-axis and the y-axis are negative, and we're looking for the cosecant. So we have x is equal to negative 3, y is equal to negative 4. They're both negative because they're located in quadrant 3, and we have r, which we don't know. So we're looking for r. We plug this into the equation, x, y, and r. We get negative 3 squared plus negative 4 squared is equal to r squared. R becomes 25. We take the square root of 25. This gives us r. So we find that r is equal to 5. So now that we have x, y, and r, x being negative 3, y being negative 4, and r being 5, we can plug this in to find the cosecant. We know that cosecant of an angle is equal to r over y. In this case, the cosecant of the angle would be 5 over negative 3. Which is the same as being written negative 5 over 3 in fraction form.